and all, Mr. Akshat, as well as all the participants, all the resource persons. I'm thankful to all of you for giving us opportunity to host this program, organize this, because this is a very important area. Today we are in the pandemic world. Most of us are sitting at home, working from home. Now, this virtual reality area is recently is becoming more and more important because it's giving us the artificial three-dimensional environment which enhances the better understanding and enhances the learning abilities for the students if it is used in the proper way by teachers. And hence, this FDP, especially for the teachers, is organized for that purpose. So, this new technique they can learn and take it ahead. I'm thankful to RUSA for giving us grant for this organizing this function. I once again welcome all of you, and I'm 100% sure that the participants will be benefited greatly in this 2-day workshop organized by GN Khalsa College under the aegis of RUSA. So I'm thankful to all of you and wish you all the best and to this program. Thank you very much.
Yes.
Over to Pratiksha, madam.
Thank you so much, sir, for the kind introduction. Now, I request, without coming much in between of the experts and the participants, I would now request Akshat to please take over the FDP program. Akshat, I request you to just give a brief about what the concept is all about, and then maybe take them through the journey of how AR/VR can be used as innovative tools in higher education. I request all the participants to please keep the session very interactive. Let's let it not be a monologue. Let it be a very interactive session. Make sure that you are able to exploit these 2 days of the FDP and make the maximum use of it. We are Akshat and Khalsa College and Akshat's team who are into developing this technology and popularizing it in higher education will also be available after these 2 days training program for any kind of tech support or any kind of educational support that you require from our end. Akshat will be will be providing you with the contact details. We are there to help you and take you through this journey of AR VR. Uh, keep make sure that you're all available at the right time, joining the sessions, interacting, having a proper Q&A sessions, and providing us with most valuable feedbacks to this program so that we can make sure that the upcoming FDPs can be improvised as per your requirements. I wish you all the best. I hope you enjoy these 2 days of the FDP program. Thank you so much for joining in with us. Akshat, please take over. Thank you.
Yes, thank you so much, madam. And also, very big thanks to Professor Mandakar sir for the fantastic introduction. And I think he really summed up, in a few words, what this FTP is going to be about. So, welcome everybody at the outset to this very small, brief, yet I hope somewhat intensive 2-day, faculty training program on these very new and fantastic technologies that I'm sure everybody has at least heard about. But today, let's hope that you get to have a closer look at what's happening inside under the hood, and also to possibly interact with all the tools and the platform that we are offering here at Devlon, that we have jointly developed with our partners. So, without any further ado, let's just slowly get started. So I'm sure participants are still slowly pouring in from within the list. So while everybody is still joining in, let's just take it a little easy, and slowly I'll start with a small introduction of myself. Now, personally, I graduated from IIT Bombay about 5 years ago, and I have been a research scientist at Sony Corporation's headquarters in Tokyo, where a lot of my work has actually been very closely related to these fields. And I was part of their vision and graphics department, where Sony has been constantly trying to push the boundaries and try to create new applications that people have not even seen yet, and possibly that will become mainstream and even commonplace, household name in say the coming few years, possibly a decade. So I have a few very interesting and possibly curious demos over here that are closely related to some of the work I did, and also what is happening with the rest of the industry in this field. So hopefully, you may like the glimpse that you get, and we will also try to dive a little bit deep into what's happening exactly when we are trying to do these things. Okay. So before we actually dive into the entire program, one thing that I want everybody to be very clear with is the objective and the takeaway that you should, or the mindset that you should come to this session with. So I'm sure everyone may have read the brochures and also gone through the brief about the program, but I think it's very important to stress that because these technologies are quite complex, they come from strong, rigorous mathematical fields that are very strongly dependent on 3D geometry and computing. It is going to be very difficult to give you a very in-depth or a very detailed ringer of the entire technology. So possibly it would be, you cannot expect to understand the mathematics behind what is going on by the end of the session, but at least what you can expect is to have a strong induction into this field, where you can catch up, first of all, to all the varied faculties and professors that we have on, that you can get a brief on what this technology is all about, and also learn what are the developments that have happened so far. And tomorrow what we will be focusing on mostly is how we will demonstrate how this is possible in your day-to-day teaching activities, and how you can participate even right now through our platform, at least those who have volunteered for few guest licenses that we are trying to interact. And hopefully tomorrow's session will be a lot more interactive. Today it will mostly just be me and another speaker just lecturing everybody, but let's not feel free to interject or ask me questions at any time through also the chat box. So feel free to write your questions in the chat, and we will keep taking them on in the middle. And finally, of course, we have been extremely excited to see that there has been a huge response from teachers across the state, and given considering that the varied backgrounds of all the teachers that are here, we had decided not to keep absolutely any mathematics in this, and we will keep it very intuitive, very user friendly, and also the main goal is to elevate your conceptual knowledge, and you will get, I want you as professors, teachers, knowledge bearers to have the confidence to speak about this technology to your peers and students. Okay. All right. So the main takeaway that I would like everybody to have is that I would like you to be the torchbearer for spreading the word about this technology at the end of this session. Hopefully that you will be able to talk more about this, and also have your colleagues and your students excited about slowly adopting these technologies in the future. And finally, because the session is relatively long, I understand it's going to be difficult for everybody to be very attentive throughout. So at the very least, what I can request over here is some passive attention, so that you can grasp at least the overall picture and connect the dots as we go ahead. Alright, so let's proceed. Okay, moving on. Yeah. So this is just a short program schedule that I'm sure everybody has seen through the brochure, and we've just had a very great introduction from the principal Mandavkar sir, and I'll be taking over the next two sessions before our next speaker, Mr. Pawan, will be inducting us on the platform before we close for today. Now, since it will be mostly me speaking today, I have just taken the call of combining this into one big single talk. So it will be slightly long, maybe an hour, hour and a half, and we'll take a few breaks. I'll be sure to ask along if there are any questions. If anybody is interested in the point that I just raised or what I just showed, and I'll be happy to get into the details of that if we have the time. Okay. All right. So moving on. Finally, let's get started on the agenda. Now, we'll be taking this a little bit step by step for the sake of everyone's understanding. We'll start with a very brief history of AVR and how the industry began, and how this revolution came about. And the biggest mystery earlier was that this is not the first time AVR has come up. This is actually its second rising, similar to another field that we are deeply involved in, which is AI. But yeah, I'll shortly elaborate on how that's going about. And of course, next we'll move on to what are the latest developments in the industry. And as we see some of the most advanced applications that are out there, we'll slowly just transition a little bit into how these things are working, into the fundamentals of 3D graphics. And there is no need to be scared over here if you are not from a computer science or a mathematics background, because most of the demonstrations, the explanations are extremely conceptual and picture or video heavy. So hopefully you will even you might even enjoy all the visuals and the images that are coming along over there. Okay, and finally I'll just transition a little bit into why it is that we at Devlearn think that it is extremely important for this technology to get into education, and for the education sector to adopt this as soon as possible. Otherwise, we run the risk of actually falling behind in training our next generation of students. So this is how we will just face the talk, and without further ado, let's get started. So before we move on, one thing that I would like to just elaborate upon is the main problem that we at Devlearn are trying to tackle, and that is the fact that most Indian students and graduates today are not prepared for an industry that is shaping itself around AI. And something that we have seen, which is very new and very disruptive, is that for the last 50 years, once or twice, every decade, technology changes up a lot, and there is a huge leap in the way things are done, say when it comes to programming or anything, and how in these last decades the change is very different than the change that we have been seeing till now. So till now, what has been happening is, although the industry has been changing, has been taking a leap usually every 5 to 10 years, or every other sector has managed to keep up with it, mostly because there have been changes in efficiency and possibly a few changes in automation. But the change that we are seeing now is more fundamental, and this level of automation is actually, there is something to worry about. So we will touch upon why it is worth considering, and what we today can do as teachers, as educators, to mitigate this problem, and also find a lane that is purely the realm of humans and human creativity and ingenuity. Okay, so let's get started. So I will just spend a little bit of time over here on this slide as we talk about the history of virtual reality. Now, to start with, this is not a new concept, although it feels like a very, very new technology. It has been conceptualized right from the 1950s and 60s, where what is I found surprising was that this wasn't in the concept of games, but it was in the concept of training personnel, and it was a military example where we are seeing this Russian laboratory that they are trying to train their astronauts or pilots in simulations on how they would experience certain things. And this looks extremely primitive. I think if you can check the video over here, it is barely a barely visible cube over here. So it started very small, and it was mostly in the realm of those sectors with a large amount of funding. But slowly from then, we started developing into came into the 90s, where the first instances of games were now visible to us. And there is one famous Nintendo console from way back then, which is the Nintendo Virtual Boy. And this is like some of the sort of quality that you can expect to have from there. Um and of course, as you can notice over here, that it is quite less low fidelity, low quality, but at least it was a start back then, and it was quite revolutionary. But of course, it did not pick up because people were not. The hype quickly died down because this cannot. There are limitations to this level of fidelity. And then came there was a little bit of a down. Uh, there was a load, an ebb in the tide. But in 2012, what happened after that was a now popular company, but was then it was absolutely a new name. Oculus uh, pioneered its first viable, next generation VR headset, and this was done through something that was not heard of before 2012, possibly a platform known as Kickstarter, where uh, people can crowdfund startups through the ideas that these startups pitch on the platform. Now, this was absolutely, this not only propelled Kickstarter into the mainstream, but also Oculus went on to develop the most successful VR headset of the time, and that eventually convinced all of the major players, that is including Sony, Microsoft, and Facebook, to join the VR race and also develop their own headsets. And now, what people noticed at this phase was that not only is our hardware capacity or even processing power has now caught up to the level of fidelity that we need to realistically, or you say photorealistically, recreate the world that we see into a virtual world, or bring our virtual world into reality. And that's when we saw the first instances of popular augmented reality applications, where a virtual object is now so lifelike or so real that if you place it in alongside real items, it is very difficult to distinguish what is virtual and what is not. And I think everybody might have at least heard, or they might have heard of their kids playing it. But 2016 was a very popular year for a game known as Pokemon Go, where everybody was hyped up around the world about this new augmented reality based application. And more and more have just kept developing so far. And now it's about 5 years since then, and what we're seeing is that virtual reality is now going to an even next level, where it's not just your sight, your vision senses that are being engaged into the new world, into the new reality, but also your entire physical positioning. So let's just take a look at some of this example is there. This is a very extremely popular Chinese product, where it is now possible for people to traverse fully created virtual environments in the comfort of their own house without moving an inch from the place where they are playing. Now, this is possibly something you might have maybe seen in a sci-fi movie, but now that is starting to become reality. And like this will only keep developing in this phase. And gaming is not only going to enter a new phase where it's not just your controller or your keyboard where you're going to play the games, but your entire body will be engaged. So not only is gaming reaching a new zenith over here in this industry, but every other industry is getting impacted by this. So let's try to take a look at what are these industries that are getting affected with these rapid changes in this technology. Okay, so before we actually proceed, I think it's important to make the distinction for to those for whom this is possibly the first time coming across these terms, about what is virtual reality and what is augmented reality exactly. So without going too much into the details, I think this image somewhat puts it into perspective, but suffice to say that virtual reality is when you are getting involved, or you are peering into a completely constructed world, right from the scratch, right down to every atom that is within that virtual world. Now, the word for atom in that world is something else, which we will touch upon shortly. But coming back to the real world is, you might find that virtual reality, although it's exciting to immerse yourself in something in a different reality, there are limitations to that. And in real world scenarios, if you want to actually have some real applications, you may want these virtual things to come into your real world so that you can interact with other people as well, and not just dive by yourself into this virtual environment. So that's where augmented reality is now coming into the forefront, where you can bring virtual elements such as what we are seeing over here, this virtual menu screen. This person is using to interact right at the comfort of his own home. And this is an extra fantastic instance of how virtual things can help you do your job, your studies, your activities, and just enhance your overall experience and efficiency of going about things. Okay, so let's just dive a little bit into what is happening in the industry now, and what sort of adoption or what sort of applications we are seeing today. So uh, just to summarize a little bit as to how business and commerce is completely getting overhauled with this industry, is that this not only is virtual reality something where you put on a headset and you're looking into a new world, but it can also be brought into your phones, your tablets, your computers. And this is completely changing the way the service industry or the ad space is revolutionized. Now, if you might have realized, with the complete advancement of the internet, ad space over the internet, advertisement has been one of the biggest revenue generators on top of the internet. Now our lives are completely glued onto our screens. Right now, even I'm communicating to you through the screen itself. And anything where any activity that involves a person looking into a screen is a possibility for a company to market themselves or put up an ad. And as we were looking into our desktop computers or our laptops so far, tomorrow when we look into our VR headset and our mobile phones that we may possibly use for VR or AR, that will be the new space for the new ad space for companies to now go and capture our attentions over there. So there has been a huge amount of investment in this space. And of course, anything that we could do with our cell phones or our tablets with face call, FaceTiming, etc. Now that would be possible to an even more immersive extent, when you can possibly do phone or video calls where the person feels much more close to you. Possibly both of you enter the same virtual space, or you can possibly overlay the person through an AR application. So this is going to not only is your very niche sector of gaming, or possibly what we will talk about in education is changing, but all fields of commerce will be impacted. And there are some very promising statistics that people have a lot more trust in companies and brands that are adopting AVR, AR, and VR to promote their business or promote their product. And that's like companies are getting the this hint, and their apps adoption is increasing a lot. So let's take a specific examples. We'll just look at a few specific examples before we possibly go into the details of the technology itself. And the biggest example that you will likely notice is what is happening in medicine, which is completely revolutionizing the way we are doing things. And it does not need to be said that the past year has been extremely crucial for the health industry, because we have been going through a constant health crisis, and innovations in medicine have been very, very vital in getting more doctors, getting the few amount of doctors to as many patients as possible, not just with respect to COVID itself, but also because doctors today are in short supply. And we especially specialists who need to possibly patients who need to travel long distances to go and see them for specific ailments. Now what is possible is that if you look at this example of remote surgeries over here, this is a small illustration on the left, where the biggest challenge in surgeries today has been, till now, or I would say, has been in preempting the surgery or preparing for it. And I'm sure some doctors or some medical professionals in here would possibly agree with me, although I'm no expert, is that half of a lot of the success of the surgery is determined by how well prepared the doctor and the team is before the surgery itself. And having augmented reality tools that can overlay the patient's current body state onto, say, any screen, or even on top of the practice operating table, that can be a very, very helpful tool for doctors and especially nurses to get a hint of, say, what can you expect, what can possibly go wrong mid surgery, or what is the doctor going to be doing sequentially. And this has now led to wide scale training of medical staff, because although there are only a few doctors in the entire hospital or medical center, it is mostly supported by the medical staff, your nurses, and all of the other staff, ground staff. So training of these staff using these technologies has been extremely monumental, and this is only going to improve here on. So hospitals are constantly, even in India, slowly adoption is starting, and they are trying out some POCs, at least the popular ones in Mumbai, on how we can adopt this. Okay, so moving on to the next application, which is quite far from our initial use case of, say, medicine, is a very commerce centric field, which is in real estate. And I'm sure it is easy to visualize that in real estate, one of the biggest challenges till now has been to convince a potential client on how the home is going to look, and what exactly is the client going to be paying for, how is the architecture of this home innovative, or how can the client expect that their home will look and feel when they purchase it, to help the client's decision. And this is usually very difficult, and builders have to take a lot of risk until that sample flat is ready, and then he can possibly aggressively market. But now what is possible is, right from the ideation stage, when just at the point where the architecture or just the design is ready, the builder is now able to market it to potential clients right away through something that you can we are calling virtual tours now, where you can dive into an app and also completely traverse the house as if the house were there, or you were looking at a video of something that exists. So what we will do is, tomorrow I will be just bringing up an example of a very useful case of a virtual house tour or a virtual locality tour that is possible on the platform that we are proposing here. So you can definitely watch out for that, and I think that would be a very immersive experience for many people here. Okay, so moving on to the next aspect, another fantastic use of AVR technologies is just closing the gap that has now formed between students and teachers and people everywhere, with the lockdown and all of the restrictions that are there. Now, this particular application is very close to my heart, because as an IT graduate, I personally missed this sort of convocation, although I had the good fortune of being there in person. But so many students who last year were at home and unable to have the experience or the memories of graduating from college, IIT Bombay did the fantastic initiative of virtualizing the entire event, and also to create custom videos of the moment where the student is receiving the degree. So I will just show you a small
Degree
clip
recipients,
of
please open the IIT
the overall the event. And this entire event was broadcast on mobile and laptops. And this is something that I found very, very fascinating, when the student over here is completely recreated in 3D, along with the director, and the moment where he is receiving his degree is now completely immortalized in this form, and they can now view it from any angle, anytime they want in the future. So I would possibly argue that this is better than just a simple video of receiving a degree in some senses. Right. So, of course, but what we did notice over here was that the quality of the video that we're seeing here is still there leaves to be something to be desired. It is very, very clearly visible that these are not real people; these are virtual people, and of course, this is all it's clearly virtual reality. So. Next, I'm going to show you an example of something that is so photorealistically made that you will possibly not even realize which part of this is real or possibly which part of this is virtually going on. So, of course, there are some very obvious elements in here, and I'll just point them out to you. But let's just take a look at this video. Now, a lot of this video is voiced in Japanese, so it's possibly alright if you just pay attention at the subtitles that are here. But this is right now the current frontier or the spearhead of what companies are able to do today. So what we're seeing here is these dancers are remotely recorded as well as live being captured by a rig of cameras and green screen, and they are being recreated in 3D and being broadcast live to you. Of course, this video itself is recording, but at the moment they were, and because this is a complete 3D recreation of real people. Now what is possible is that you can, because this is a completely virtual world, your camera can go places where a real cameraman could never go. And that includes flying in the air, going even underground, or possibly to places where a camera person possibly cannot, be extremely close to the dancers, do a lot of lighting, completely pan over, this sort of camera work usually is only seen in the movies. But with this technology now slowly becoming a reality, it is possible for companies to even do this with live events. So I would say that this is possibly going to be the next method for people to consume video content, and it's not going to be just the simple 2D video of you watching the live broadcast of one camera feed, where if you are watching anything on television, it's not going to just be that simple camera, but you will also have the option of doing all the fantastical
degree
camera views and angles as you go along, and watch the same content in a method that you want to watch it. And this will give a level of freedom to people that has never been given before. So if I as a person am only interested in watching content in this format, but you are interested in watching in some other way, you both have the freedom to watch in whatever format you like, and that is what is possible now with this 3D reconstruction in augmented and virtual reality. So let's take a short look at how exactly is this happening. Now, what is going on under the hood where it's possible for people to look that realistic and still not be real people, still be complete 3D models. Now, how does it work is that there is an extremely elaborate hardware network that is gone behind the creation of this. But let's suffice to say that, okay, I have an example here of a rig that Google has made. And the example we saw was for a different company, Sony, but the base or the core technology is extremely similar in the fact that your subject or the person who is being recorded is standing completely surrounded by cameras. And these cameras are all working in unison. They are synchronized, and they are all capturing at the exact same amount of time. So at any instant of time, all the cameras are aligning the picture that they are taking. And with that, what is possible is, of course, with some algorithms that possibly are out of the scope of this discussion today, what you can get out of that is a very, very high fidelity 3D model of this same person, which they have reconstructed through computing. And on top of that, what they have done is you can clearly see that this is, a virtual model that is created, and it is colored with the exact same shades and hues that the person had. And it is possible to do that because there are real pictures of the person, who is standing in that exact pose. And now with this extremely high fidelity, something that we will call photorealism. So because it looks as real as a photograph, this photorealistic reconstruction can now be used wherever you want, whether it be in a completely fictitious studio, or another inside a game, or inside even say another application. So now that is yours to use. So this person has now, at least in this one time instant, been immortalized into one photorealistic 3D model. And what they are doing is that this, if you if you continue to do in real time for as many frames as you have in say any particular video or any stream that you're broadcasting, it is now possible to do that and even share it with people live. So this is an example over here what we're seeing, where that entire process that I mentioned of capturing that person, reconstructing them, and also texturing them is now done live in real time. And this large amount of processing is now possible through an entire array of computers. So what exactly you would say is, okay, this all looks great, but and sports is one application potentially for this, but another huge application for this is also in the movies and movie theaters. As you might have just guessed right now by looking at this, is that they have put tremendous amounts of money, and the next frontier for this is going to be where you possibly don't even need actors many of the times in certain scenes. You just need recordings of them, and you can use them the way you want. So let's just take a look at this one scene cut that is developed by Intel using this exact technology. And the exact same scene is now, they can freeze it in time, move the camera however they want. And this normally was not possible. Some of the attendees here might be thinking about the Matrix when you are looking at this. But the Matrix was using a technology that is known as bullet time, where you had a huge amount of cameras placed. Again, it's a large amount of cameras, but with bullet time you can only view the thing in say a very very limited range of freedom. So your camera does not have the freedom to move wherever it wants. So this is now putting you spatially into this world, and now you can see it from wherever you would like, even from under the ground if you would feel like doing that. So we will just touch upon how this is happening in a session shortly after this. So let's just dive into that and just see how that looks a little bit. Okay. So we just had a look at some very very fantastic examples that are happening out there in the industry, and how they are using AR and VR to completely revolutionize the current way that business is done and even industry is working. So before we go into how they are trying to do this, at least what are the fundamentals behind this, let's just stop to hear a few questions. So are there any questions in the chat if anybody would like to bring up any point? If anybody has anything that they found even mildly curious or interesting, maybe they would want to know more about that, what is happening, just you can feel free to ask me right away. Okay. So I think there are no major questions at this stage. All right. So let's just move on with the session. Possibly many people might still be wanting to hear more about how we can go ahead with and what's happening under the hood. Okay, I see. I think we just have had one question right now from Gaikwad sir, who mentioned whether we can create our own models for AR. Yeah, it is possible, absolutely. So the core concept for creating a model, whether it be VR or AR, is actually the exact same, and it's only the application endpoint that is different for them. So whereas in VR, that same model you are putting into a completely virtual world, in AR you are just you're designing an app where that same model you are now putting into the real world, and the experience of that is possibly say using the camera of your device, be it your mobile phone or your tablet or your laptop, or even say your head mounted display. But the process for it is the exact same, and it is definitely possible to create VR and AR models exactly the same. All right, so I think we can tackle one more question right now. Okay, so our core sir says whether models of temple architectures and maps can be created. Absolutely, yes. So this is a very exciting application that is possible of extremely large structures that can be modeled, through very, very few devices. Now, some of the applications that I showed you are, of that use extremely sophisticated hardware. Let me just go back to. Okay, let me just show you this rig over here. Now, as you can possibly surmise, is that this rig or setup is incredibly expensive and possibly cost millions of dollars for the company for them to create something at this quality. But if you, as at your level of a professor or a student, you want to do this sort of modeling on your own, it is possible now. So using just a stereo camera on your phone, which is now coming since I think 2017, all phones have at least 2 cameras on them. So stereoscopic 3D reconstruction should be possible. We'll possibly, if you're interested, I'll be happy to touch upon that tomorrow. The concept that you are looking for to do this is called photogrammetry, where if you are in a very large space and you want to possibly record the shape of that structure, you can just with your mobile phone and possibly an application running in the background, you can create at least to some extent a good reconstruction of that place. So we will of course be touching on that as well. I think that's something for tomorrow's session. So you can possibly just hang on, hold tight for that. Okay, so the next session will be a little bit slightly more technical than this one, and we'll be talking about how exactly 3D graphics are working inside this entire pipeline, and let's just try to break it down a little bit and just look at how they come together to form, say, a new virtual world. Okay, so I will try my best to simplify this for all the faculty that are sitting over here. But if anybody does not understand any aspect, if you would say like me to clarify, what this one part is doing, I'll be happy to answer that as a question. We can definitely tackle that post the session also. So just to keep it brief, whatever happens within each process is every application, regardless of what is happening, where what is the use case for the graphics that is used, whether it be movies or it be sports or it be gaming or anything, it goes through the exact same 3D graphics pipeline, which is what I have written down here, and that is the process of is broadly divided into 3 sections. That is of creating your model or your world, deciding how it is seen through the camera, and then finally doing some calculations on how this 3D world is translated to your 2D screens and then brought to finally your phone screen or your laptop. So I think it's very important to say that despite our physical world being 3-dimensional and something that we can touch and clearly see, everything that we have experienced in 3D so far on screens is eventually two-dimensional. It does not need to be said further, but the fact that this two-dimensional information is coming from what was originally three-dimensional is the crux of what is happening in computer graphics. So I think what I have over here is a camera, and like I think many might have thought that this was just a 2D picture of this, but what I can do is that, if I can move this camera around, it can create at least the illusion of depth, where you can look inside, look at the lens and the body, and feel that the camera is actually having a solid structure, and you can probably have a sense of its size. So all of this is possible. This, what you're seeing right now, is happening through this entire process that is constantly repeating itself. So let's just touch upon a little bit on what each of these processes do. And moving into that is, of course, here let's just limit ourselves to an instance of creating something in virtual reality. And the first point for that is to have a virtual world or a scene where you can build your object. And within that is when you actually start building things, or you bring something that is already built, and that is your phase of 3D modeling, where this entire pipeline that you're possibly seeing on your screens starts with the basic object that you want to experience or that you want to observe in this virtual world. Now this object, you can create it whether on your own, or you can just simply import freely created objects from other artists all over the world